There's a lot more setup in TIG welding. 2 to 3 times its diameter is how long the point is. If I angle in the direction of travel, now my puddle gets a little bit longer. All right, so I just got some 1/16 S2 filler wire. There's S2 and S6 are the most common for steel filler wire. S2 is a little bit softer. S6 is a little bit stronger. They're probably both fine for everything you're doing, let's be honest. But if you're doing sheet metal stuff, guys prefer S2 because they're gonna be hammering it. Chassis stuff, S6 is more common. It is really important to have your stuff quite clean when you're TIG welding. There's a lot more setup in TIG welding, I think. You have a little bit more settings, you got more things to consider. You've got to grind your tungsten to be sharp. Ooh, we should talk about that. Most welders now, you can just grind them totally sharp. But for the most part, your angle of your tungsten, your sharpness, for me, I go like maybe twice its diameter. 2 to 3 times its diameter is how long the point is. Kind of a rule of thumb. And you can have a look there. It's just a sharpened pencil, basically. Don't overcomplicate it, you're a beginner. Okay, the other thing is you really want to be comfortable when you're holding your TIG torch, when you're sitting, whatever weld you're doing, comfort is key because how stable you are is directly related to how comfortable your arms are and how much range of motion you have. So if I'm gonna do some kind of a joint here, I wanna make sure I can get as far as I wanna go before I'm gonna stop that weld. So if I want a 4-inch long weld, what I'll do is I'll get myself all set up. I'm not gonna hit the pedal yet, and I'm gonna try and move that whole 4 inches without, you know, reaching or whatever. So if I'm gonna do, say, a T-joint like this is very common. I'll do something like that. Do I want my angle like this, or do I want it in the direction of travel? You kind of want 45 degrees if it's a 90-degree corner. You want this to come in at 45 degrees, but you also want to angle in the direction of travel for a couple of reasons. One is that when you are angled in the direction of travel, that's where your puddle is. Your puddle becomes, instead of your puddle being a dot like this, if I angle in the direction of travel, now my puddle gets a little bit longer. With a longer puddle, now I have an area in front of the torch where I can dip my filler rod, okay? So if you go vertically like this, you have a really good chance of putting this filler rod directly into the tungsten, which you don't want to touch. It just doesn't work. If you do touch the end of the tungsten, it's okay, but you got to go sharpen that thing. So if you're a beginner, I suggest get yourself a pack of tungstens. Don't buy 1, buy 10, and sharpen them all, and have them all right here, because you're going to start swearing and be bummed every time you touch the tip, and you're going to do that a lot, I promise. Now I'm going to tack, just like MIG welding, if you ever heard before, like you tack hot, right? So I'll stab the pedal all the way down to get a tack, because right now the material's cold, everything's cold, so you need a little bit more heat to get anything to happen. I already like about this machine is that the fan is not on 100% of the time when you start welding. It actually has a thermostat that will turn the fan on once it heats up enough that it needs to be on, and if it cools down enough, it'll shut itself off, because there's nothing worse than hearing whoa like all day when you're not actually welding. So for our T-joint, I am angled approximately 35 degrees in the direction of travel, which is this way, and I am about 45 degrees this way. And basically what I'm gonna do is I'm gonna build my puddle, like I'll put the heat down, I'll see the puddle form, and then I'll add a bit of filler, move along, add a little bit of filler, move along, add a little bit of filler, move along, add a little bit of filler. That's how I'm gonna do it. So I'm gonna do about a 1-inch weld right now. So I just wanna make sure, can I do 1 inch steady like that? No problem, no problem. Oh, I just touched it. That's what happens when you touch the tip. Gets a little bit of a ball of build up on it. So I can give that a sharpen right now. We're gonna try and repeat the same weld, just better. All right. What I notice is that the arc is like really stable. Like the puddle seems quite sharp, if that makes any sense. Let's give her another go here. Let's try an outside corner. So same deal. I'm pointing in the center of the joint itself, and I'm gonna angle in the direction of travel. I'm kind of pulsing my foot a little bit. It's just sort of a habit of mine. I like to mechanical pulse. So as I dip, I'll add a little bit of foot pedal, and when I move over, I back off just a little bit. Because as you add filler material, the filler material is cold, you're introducing something that needs to be melted, right? So it needs a little bit more power. That would make sense when you're adding filler material. And when you're moving over, you're just moving, so you don't really need full blast because you're not adding any material. Here's another filler material that you might enjoy playing with. Silicon bronze is a lower melting temperature filler wire. So it's almost like brazing. It's not technically necessary for the steel to become molten for this to weld and adhere. It just saves you a little bit of warping. Also, it's great for if you're building up some material and it's easier to grind because it's soft. You can build up material around some bungs on a gas tank, on a motorcycle, and you could grind them all smooth, and you could do things like that with it. So check out silicon bronze. You can get it as a filler for MIG welding as well. I know it's very well used in body shops nowadays that are just doing collision repair for the same reason. It welds nice, gets a nice fill. Okay, we'll do a little vertical up weld and just see how it does. Yeah, it welds nice vertical up. Okay, a little vertical down, 10 gauge. That was some steel. I think let's do some aluminum.